Hello. I will do this thing. Oh, okay. We're good. That link works, right? Let me check that. Yeah, okay. Good. Hello. I will talk in a sec. Uncle. What is with uncle? Is that a reference to something? Okay. Good. So I almost exclusively do it in my head, which makes it not the best thing for streaming. But yeah, it's mostly going on in my head. Over time, I've greatly increased my mental capacity. Third year college. Okay. I've turned this up a bit. Is the volume better or is it too loud? For those of you who are here, how is the volume? Or is it still too quiet? Because I can turn it up more. I've thought about yeah, it's pretty quiet on my old streams. How long? At most 6 months, hopefully less. Depends on just how better I get over this month and so on. It'll take a while for me to actually like get the content. Okay, it'll take a while for me to actually like get the contests and stuff. Okay, let me Hello, does this help or not? Okay, I'll do it in between then. 12.5. Okay. I guess that's fine. I have not looked at the editorials. Ah, nice. Okay, that makes sense, I guess. Sure. If you insist. Okay, so problem solving. Here we go. Give hello 2024 from alt. I'll just virtual it. It's fine. I have a virtual rating. Gonna be doing contests regularly now. No, I'm gonna be doing virtuals regularly, which I have been doing. In fact, I have a log of the virtuals. And stuff. Are there any new topics? Not really. No. I haven't really learned anything new between like even Orange and LGM, even Orange and where I am now, and I don't intend to. Maybe a little bit between Red, but I don't. There really wasn't that much that that was useful to me. It's pretty much exclusively just think, do problems, get better, get faster. That's all it takes. AMC and Amy. I never really did them, but I mean, math Olympiads are their own thing. Like, I'm not sure what thoughts would entail in that sense. How do you get virtual ratings? I will show you. There is a thing where there's a bot in this server. It's called TLE. join that. And then if you type in rated VC, if you link your handle and then type in rated VC, it will, and then you do the virtual, it will give you a rating for it. Yeah, that's easy. Or you can use other ways, like for example, CF Visualizer, which is still a thing after all these years. You can put in a contest and see how your rating would do. Okay, yes. Cool, let's do a problem. How do I stay so consistent? I have nothing better to do with my life. That's ultimately what it boils down to. That's my source of motivation. I have nothing better to do. Nim 2. Cool. Number of shortcut positions and the number of initial positions that need to be evaluated. We're racing. You have 2300 with you? Okay, I don't know what difficulty is. I think it's like 31 or 32. I don't know. Probably 10 hours only for like this month, and then later I have to start doing YouTube stuff again. So it won't be as long every day. Yeah, okay. They're in shortcut positions, yeah. Okay, so I'm thinking in terms of Grundy, it's... Thinking in terms of Grundy, it is, something. Number of stones in the first and second heap, respectively. I don't really think so. I don't think I learned game theory formally. Yeah, probably like red, I guess, is when I like seriously looked into the theory. I think it was during a screencast even. I don't remember. So I mean the games are not independent anymore, which means our state is a pair. Um, so if you can reach a shortcut, you're a winning state. Therefore, any state that can reach a any state that can reach a shortcut is winning. Any state that's on a shortcut is losing. Which means that any state above a shortcut is taboo. How long is your college break? It's like a month and a week or so. I'm about halfway through right now. I have 3 weeks left. Okay, so we don't actually care about Grundy numbers. We only care about ones and zeros. Because like it's one game. So yes, Centroid decomposition is divide and conquer on trees, so understanding it would help a lot. Actually, there are like two types of centroids. There's like two types of centroid decomp. There's like the query version and the divide and conquer version. The divide and conquer version, it definitely helped understand divide and conquer. Centroid like divide and conquer on trees is just finding a split point such that all of the trees are at most half size, and they just do divide and conquer that way, same as an array. And the other half is weirder and harder and separate almost. Constraint preferences. I kind of don't like 1e5 actually. I like when it's more interesting. I don't know, 1e5 is it just lends itself more to like staleness, I guess. Okay, nim shortcuts. I think trying for a long time is good, pretty much at all levels. I would recommend Omnic's blog for a quick reference. His thing on practice. That's generally the philosophy I align with. See the description for like my recommendations. We have two piles. I mean, something about two piles, right? If I can reach a shortcut. So anything without a shortcut in sight, obviously. So considering like the lowest shortcut, anything without a shortcut in sight is going to play to the normal rules. So if the leftmost shortcut is at 4 and we're at 3, then it's by XOR, which is obvious, but that lends itself well to what? What if we like do it that way? So anything to the left of the first shortcut is going to play by the normal rules. Consider the first shortcut, right? Wait, so the only difference is that the... Oh, yeah, okay. The only difference is that it adds some losing states. Or it changes where the losing states are. Changes where the losing states are, right? Yeah, so the number of losing states is not that many, right? So if we consider the table, we have a 0. Then on this row, Oh, I see. I see how this works. Clever problem. Yeah. Well, this doesn't, it doesn't work yet, but it goes somewhere. So the 0 is at the lowest point where there's no 0 to the left. Or it's at a shortcut. I see. I understand the pattern. Okay. This is actually very insightful to game theory. Like this is this is actually really cool. I should I don't, it's 3,000, but this is like a cool problem. I think I would recommend it to people. How'd you deal with losing? I did. I'm not the one to ask for that, man. I'm depressed. I'm depressed as hell. I'm not the right one to ask for that. I still don't take failure. There are some coping mechanisms. Like the first thing is like for things like Codeforces where you get a chance to try again, then you can like fix the reason that you failed. Like understand why you failed, fix it, and then convince yourself that it won't happen again. And then like don't let it happen again. And that's how you can get over the root cause for failure. If it's something that you're gonna like, if it's something that's like you get like one chance at, like Olympiads, then like I don't know. Like personally, I've realized that like no matter what it is, I just eventually don't care about it. Like whether I do well or not, I'm just eventually not gonna care. It's gonna hurt in the moment, of course. Like it's always gonna hurt in the moment, but over time, like I don't know, I personally just stop caring eventually. It just doesn't bother me anymore. Okay, so closest real job to competitive programming. I don't know. Probably quant, I guess. No, not really. People say it's quant. People like to use quant as an answer to that question, but I don't really know. I don't know that much about real jobs. I mean, software engineering is like programming. Quant is more the math side. And you probably don't get a thing with both. It's hard to tell. It depends on what you prefer. Like if you like the programming side, then yeah, software engineering makes sense. I guess quant is more algorithmic in that sense. It's a cool problem. I like this more than D already. Like I already like this more. I mean, D was cool. It was just that ending part, man. That was frustrating at best. I don't know anything about quant, pretty much. Only anecdotes. Like I have no personal experience with it. I wouldn't know. Sorry. Okay, wait. So it's gonna look like this, right? So shoot. Okay. So Wait, no, pause is 0. Okay, so initially, right? You're 0, 5. You're gonna be here. You're gonna be here. You're gonna be here. You're gonna be here. Insert you here. You're gonna be here. Okay. 30. Yeah. Okay, so here we are. Okay, so good. Just to confirm. Set. So, what are you doing? So for each thing, right? Okay, so So spec.count p else for x at p. What do you? So your z dot insert x while z dot count else dx is equal to spec dot lower bound p So while z dot count h, assuming spec is not here. At p dot insert h. Okay. That's wrong. Else. Oh wait, no. sh dot push. Okay, come on. If run sh dot clear. Okay. Let's see. So 0, 0, 5, 1, 2, 4, 8, 2, 3, 6, 5, 9, 6, 4, 7, 10. Okay. Beautiful. Now if run c to x to y. Okay, good. Now answer is PLR is equal to segs dot lower bound. Okay. L P is equal to R dot S. L is equal to V dot S. R is equal to V dot F. If L is equal to R, if at L dot count, return at L dot count Y. Else assert at L dot size equal to 1. L of v is equal to L dot begin, return v plus x minus L is equal to y. I is 0, j is 0. Wait, what? V is 0, 0. Oh, wait. This is losing. Beautiful. Okay. You idiot. How do you... Okay. Cool. Why is this an extra channel? Just because I don't want to flood my own channel with competitive programming stuff, especially since it's not like as relevant to my main channel anymore. Work. Good. Okay, 2 seconds. 3100. Nice. Blitz, did you beat me to your 2300? That's 31? What? Oh, got a lot of solves like throughout. That's kind of a scam. Good stuff. Good stuff. Hard contest. Very hard contest. Okay, so we move on. What is with the nose? Okay, this contest. I am not going to touch this one. I have perhaps done this on an alt and it went terribly, so that's cool. Actually, maybe we'll look at, have we done H? How hard is H? Oh, okay. We can do H. Yeah, sure. H1 at least. Okay, so the expected value part is not interesting. What we're interested in is the total number of crossings, right? So how's this work? Hello, Kevin. What's up? Longest increasing subsequence. Nice, very nice. Is that all it is? It just asks you to find them. Nice, very nice. Coloring C is chosen. Ah. What are the updates? You probably can, yeah. This one's what, like 2,900? It's kind of hard. It's gonna be like 34. Well, this is 2,700? Yeah. Sure. Sure indeed. What? It's a number of crossings, right? It's not just like the number. More. How many are there? All right. Oh, I see what you mean. Nice. Too good, too good. Yeah, too good. Damn. Yeah, get to choose. Choice is good. Did you not? Did you not finish yours? That problem wasn't that bad. I think it was. I had a much easier time with it than D. Although they were the same difficulty, so makes sense. Nice. Get to it. Don't let me finish 2 before you finish 1. Although this one's not. This one's like 2900, so it's more reasonable. Achieve it by assigning colors to the uncolored spools of S. Right. Yeah, sure. Compute the expected value of f of c. Find it by modulo. That thing. Indeed, we have modulo. So I mean, it's like, so of course we're gonna pair odd with odd. So if we list out the odds together, so if we list out just the odds, so we ignore the evens. Wait, so we're doing like double listing? Hang on. What is going on? You better be almost done with lists. There are like a million ways to do that problem. I'm gonna do some more virtuals soon, probably at the end of the winter break. But real contests, probably not for a while. They're end spools, yeah, so. Okay, so we take all odd length strings. And then we, so we rotate the strings so that all groups are like that. And we take all odd length groups and reduce them to 1, and take all even length groups and reduce them to 0. Okay, I see. So what we're doing thus is take any evens that are together. We take any two that are together, and we just remove them. There's no reason to not remove them, so we might as well. So we do so repeatedly. So B. So we're going to be left with a string that's like BW. We can't ever have an odd length string. We can, okay. Okay, so first observation, circularity doesn't matter. Yeah, circularity doesn't matter. So now we can yeah. So now we go through this string, right? Our state is that we have an alternating string of length x ending in y. Our state is that we have an alternating string of length x ending in y. Then to add on another thing, we either decrease it by 1, increase it by 1, or do neither. No, we can't do neither. No, either decrease it by 1 or increase it by 1. The problem is we could exhaust the string. So that gives us an n squared dp, but it's not fast enough. Okay, now let's compress the initial string. Yes, OI is definitely more algorithm intensive. You probably need more knowledge for those. I'm doing a virtual every day, but it's just at Coder. The problem is I'm like almost out of div 1s. So I need to be conservative with them. That's how I'm doing at Coder, because there's like infinite of this. Until I run out of at Coder, and then we'll have a problem. Then we'll do IOIs or something after that. Should I take a well, by then I'll be LGM, I hope, so should be fine. I'll probably mix up the format a bit too. Well, just for my own sake of not going insane. Might vary what we're doing. Okay, so here we are. Here we are doing a thing. Okay, wait. So, idea. We have no. What it? Wait. What it? No, right? It's like BW and WB are going to produce different states. But do they? Wait, but do they? So we know they're at an odd position. Right. If you start at B, you're going to end in B. If you start at W, you're going to end in W. So we have like a plus and a minus, right? We need to make sure the coloring is actually reachable too. That's actually kind of a pain. How do we do that? The final length of the string needs to be 0 mod 4. Okay, yes, that's true. So if you're odd, right? If we have BWB, then you will extend or you will subtract. I have idea. I have idea. So we have state. And this might kind of extend to the updates version too. We need to think about it some more. We have state. How good use code guide? It's good for learning things, I suppose. Depends on what kind of competitive programming you want to get good at. If it's Codeforces, learning things is not that useful, so it's not going to be that useful. But if it's something like Olympiads, ICPC, stuff like that, that are a lot more knowledge focused, then yeah, it'll be good because you'll need to learn things. So every question mark is the same. Okay, so send and queue. SI is equal to question mark. So white is 1, black is -1. Bow is -2, CQ is 1. Okay, now B is equal to CQ minus 2 times D. Mono. Should be 1. Zero. Oh, what? You can be -1. Wait, how's bow? Oh, else. Yeah, okay. You should be 9, 18. Oh, yes, okay. Ants is equal to beautiful. Okay. Cool. Cube problem. Same to end a cube, balance 0. Ants is 0. Alright, now we look at the hard version, I guess, because why not? What I recommend for IOI. It's still kind of the same strategy. Like, you need to look at the problems, see what knowledge it takes, see what you need to look at the problems, use them to gauge the knowledge you need. But there's also like syllabi and stuff, like the IOI syllabus. You can use that to also determine what to learn. I mean, of course, the answer is always to practice a lot, but in terms of figuring out what you need to know, you can both gauge that from the problems and look at like syllabi, stuff like that. That's struggle. Define easy. I mean, how much do you think problems have changed? A lot, so much. Blame Anton for that, but it is very different from how it was 5 years ago. Yeah. 2900, yeah. Okay, so H2 now. What we need to do is speed this part up. So the balance we can maintain, that's fine. What is with the nose? Every time I solve a problem. Okay, so I mean, this becomes a combo task now, right? What kind of task does this become? Well, the problem is that the number of question marks changes. It can change by a lot. Yeah, I do mean that CF doesn't need knowledge. I mean, the source is Codeforces. Just open Codeforces and solve some problems. That's all it really takes. Okay, so we need an affine, right? Like, we might not be able to do this because this seems like a combo task, which I'm not the best at. I'm very much not the best at. We'll try for a bit, because why not? Try for like 30 minutes or so. Right, so like this is where it gets hard. We have updates, we have queries. Expected value of f of c initially and after each update. Does this extend, first of all? Like, does this formulation even work? Read into end to q. Right? So keep track of the number of question marks. We're changing by one character at a time. Like we have a certain balance. One such thing is decided. I mean, by that definition, the problem I just solved was easy. But I mean, yes, like there are problems I can't solve, and most of them are not knowledge issue. I mean, usually when I can't, like almost always when I can't solve something, it's not a knowledge issue. That's a pretty fast 2900, huh? That's good. Yeah, it was like 30 minutes. Good stuff. Good stuff. See if we can do H2. Each one has like way more solves than G, right? Yeah, it would. Communism. Yeah, I mean, yeah, usually it's skill issue, not knowledge issue. We have 4 seconds. So we're gonna move the interval, right? So I mean, if we so like, what's initially reachable, right? So considering we have no question marks, consider that every question mark is initially white, right? Then we have some question marks. And that lets us change the balance from, let's say everything is initially -1. Then we have some question marks, and it lets us change the balance from -1 to 1 for an arbitrary amount of things. We need this like decreasing and increasing sum. So we start here. Down to 0. We need CQ choose K times F minus 2K. F minus K over 2, right? Let's say our balance initially is -12. Then we need CQ choose 0 times 3 plus CQ choose 1 times, no, plus CQ choose 2 times 2 plus CQ choose 4 times 1 plus CQ choose 12 times 1 plus CQ choose, yeah. So how do we do that? Well, the sum of K and choose K There's like a special element, but it's not K in choose K. It's something else in choose K. And it's not even that either. Sum of K and choose K is n to the n minus 1. That makes sense. This is not K and choose K. It's something else. Right? We're like, and it's not even like, it's not even all of them either. It's like only some of them. Could have BW, right? And then you'd be all bad. I mean, we probably can't do this, right? I mean, what we'd be asking for is a lot. We'd be asking for a lot. Yeah, pretty much. It's never knowledge. It's always something like that. Just missing an idea. Why would you FFT this? Why would you FFT H1? Like, why would you do that? What's the point in that? Okay, so I mean, this is our process. This might be... is this as reduced as the problem can get? And we have ourselves a pretty clear process. Did you finally finish it? I did finish H1, by the way. Yeah. Nice. Very nice. Where is it from? What division? Random, unassuming question. Okay, sure. That's fair then. n equals 100 and O of n cubed. Was that intended? Okay, so we have a reachable interval. $2,300 div3g. Nice. Where is that? Which div3 is that? There aren't that many of those, right? I think I've seen a couple 2400s from div3, but like not that many. They're usually like DP and stuff's scary for div3 people. Scary for oranges even, I guess. If a div3 problem went unsolved, it could get like 2800 or 2900 something. That'd be kind of crazy. 3,000 from div3. Imagine. $916 G2. I look at this one. Oh, this one. Okay. Wait, what? Have I looked at this one? No, I haven't. Okay. Whatever then. My laptop is almost dead. That's cool. Okay. Oh, you got... Nice. Okay. Oh, it could be even harder, honestly. And sometimes I can't solve them. I don't know what's with that coder, man. That coder's just weird. I don't know why I do so much worse. I guess I'm just used to Codeforces. Codeforces doesn't have a coherent style, though, especially with the variety and coordinators. Cough. I don't know. I don't know what it is with that coder. I'm just worse at it. Thoughts on the goodbye? I don't like Googleable problems. I really don't like that. It's quite a shame that that became 2600, and therefore I would get a terrible performance if I didn't solve it. Do I ever feel like coordinating? No. I just don't feel like it now. Okay, so we have like negative 2n. I know, from negative n to n. We have from negative n to n of stuff. We have from negative n to n a choice to make. Have from negative n to n a choice. Some of these choices have been made for us. And choose k. Blah. What are we doing? Do I feel like setting a problem? I have in the past for like my school contests. They were not terrible problems. They weren't great. Probably for a round. No. I don't really have the skill. Don't really have the skill to do the thing. What am I saying? I don't have the skill to the problem set, like to make good problems. I don't really want to work on that. Sorry, my head's something's happening to me. This problem is messing with my brain. H2, does H1 have the... Yeah, it has that extra thing. I don't know, man. This seems kind of hard. We have like have a Pascal's triangle. And you go from negative n to n. You go from negative n to n. Go from negative n to n. Okay, we can scrap the over 2 thing, because the over 2 is constant. So now we have k and choose k. No. We have k and choose k for odd size subsets. But it's not all of them either. Yeah, now to do this, we need prefix sums of n choose k. And we need... Okay. This combo thing isn't working. Which means we need a new formulation somehow, right? N spools of thread placed on the rim of a circular table. So yeah, we're going to iteratively remove u. And the answer is the length of the string over 4. And we're going to iteratively remove stuff. And the only reachable value coloring is B, W, B, 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 W, W, W. Reachable. How much is this? That's 34, right? Do we need to do this problem? It's gonna be 34. Kind of hard. Seems kind of hard. Yeah. I mean, that gate keeps 2950. Yeah, let's do something else. Okay. Whatever, we'll leave it. Well, we finally saw something from this round. It's not bad. U we haven't looked at. U we can look at D, I guess, right? Yeah, sure. Okay. So we'll leave this. Hard combo is hard. Today's the final contest of INOI. Contest remains a row within computers. All computers a number of integers from 1 to n from left to right. Like M. For AI. Is the computer behind which the ith participant want to sit. Yeah, I'm switching. 3400 combo is impossible for me. I can do 3000 combo, but 3400 combo is kind of it's kind of rough. I'm gonna spare myself the pain. Sure. This one's 30 or 31, 3000 or 31, so we'll see. 30 or 31, yeah. 3000. 3000 is 3000. You could say that. Okay. Bring it. Okay, so consider all pairs of array A, B such that no person becomes a set. For each of them, let's calculate the sum of participants' madnesses. Okay. So we're allowed n cubed. Um, consider all pairs of arrays A, B such that no person becomes upset. Such that no person becomes upset. Hello from Iran. Yeah, this is appropriate. Hello. I think this is an Iranian round. Yeah. Three possible arrays A. Wait, what? Oh, yeah, okay, sure. Goes to sit behind the AS computer. Is occupied, he keeps walking in this direction until he reaches the first unoccupied computer. After that, he sits behind it. If he doesn't find any computer, he gets upset and gives up on the contest. Reasonable. Very reasonable. Just gives up if he can't find a seat. Nice. All right, so okay, so we have some stuff going on. If we didn't have the upset condition, life would be a lot easier. Because we do have the upset condition, like... Right, so... Okay. For the ith participant, let's find all the ways in which they can find all the ways in which they can join a component of size k. Components are labeled, which means we can reorder them however we want. Right? Okay, so let's find all the ways in which you can join a component of size k. Which means so there must exist a component of size k. So suppose we fix that there exists a component of size k. Right. Yeah, G problem G was 6 seconds. Yeah, have fun with it. I'm having fun with this one. So we can iterate over the person, and then their target seat, and then their final seat. And we know that I mean, it might be easier to do component of size k, right? Iterate person. and component of size k, component size submit, why not? Yeah, sleep is good. Sleep is definitely good. It's 3 p.m. for me right now. A lot of people, it's night. Submit. Do it. Submit, why not? It's practice. Best possible mindset. It keeps walking in this direction. The answer is not a power of 2, right? That would be lame. Yeah, I see. Sure. Why don't we screw the person thing? Let's say for each component, let's count the number of ways. Let's say for each interval, suppose this interval ends up final. Count the number of ways for this interval to end up final. Why don't we do that? So say dpij is the number of ways to fill I with this many people. dpijk, fill I with j people such that something, right? But components can touch. We just assume they can't interact. Well, wait. If we assume that you're constrained to this, right? Yeah, if we assume that you're constrained to this interval, right, then nobody ever lands outside of this interval. And nobody's going to ever try to land outside this interval. So to get a component of length k, right? This is such a combo problem, man. Such a freaking combo problem. Oh, wrong answer. Shame. Shame. See, when I do it, it works, so suck it. Yeah. Okay, So we want to count the number of ways to have a component of size k. I want to count the number of ways to have a component. Okay, we have a input mod, because why not? I want to count the number of... Just focus. Count the number of ways to have a component of size k. So how do we do that? So we can have two components that don't interact at all. We can have two components that don't interact at all. No, we can have a partition of components that don't interact at all. We can have a partition of components that don't interact at all. We don't have to do n choose k at all, actually, because we can just factorial the final order. Okay, cool. That's nice. No, that's not how that works. No, that's not how that works at all. So we can have two components that don't interact at all. Or they do interact. So we land on U. And have a partition of components that don't interact at all. Or we can land on U with left. Or we can land on U with right. Alright, then we're going to assume that components are disjoint now. Well, what if we okay. We could assume you don't interact. Or we could assume you have to interact, right? Well, we could have components that don't interact. And then suddenly we have something that lands on you. If we have two components that don't interact, let's say we count you there. This is trippy. This is trippy. This is really trippy. Combo is so annoying. You never know what you're allowed to do. So freaking annoying. I don't know, man. I'm coping. I'm coping hard, but that's combo, man. You never know what you're allowed to do and what's wrong. You never. I feel like when you get to the point of being LGM, you should have a better grasp on combo than what I do, but somehow I just bash through problems and it works and it gets accepted and then I just move on. I don't know, man. It's rough. So we can have a subset of components that don't interact, right? Problem is, will we count the same component twice or not? Like we could get U from here, and then U from here. and then U from here. Yeah, that's going to overcount. That's going to overcount. What if we do some semblance of chrono order, right? What if we have a semblance of chrono order? No, but no, that doesn't work. Damn, that's a shame. When would we have chrono order? Like when, man, when? When? Yeah, with edges, you never know. It's kind of annoying that way. That's why I don't like doing problems from them. At least the hard ones. Any, actually. You never know if it's... But recently it's been better about concepts and stuff. They're still designed to be educational, but they're more like aligned with CF style. Three, two. We can't just tack on chronological order and say that it's gonna work. It doesn't work that way, man. Okay, so we need some sort of unifying factor. We can say that our components can't be disjoint. That would work. That would totally work. We can say that our components have to be coherent somehow. We need to count the number of non-disjoint components. Right. Count the number of non-disjoint components. That is our task. How does one do that? What does it mean for a component to be disjoint? What does that even mean? It means that these two components never interact, right? So before a transition, we can take a bunch of disjoint components and then add one to them, right? What does it mean for two components to interact? we need to get these definitions straight. I did not do math Olympiads. I avoided them like the plague. I did not enjoy them. Avoided them like the plague. I'm not good at avoiding plagues, evidently, because I'm still here, but... Now I'm doing a combo problem, of course. There's so many combo problems. There's no escape. There's no escape from combo. So what does it mean? Okay, so we're saying that you have to be not disjoint. What the hell does it mean to be disjoint? Like, what is it? It means that these two components never... What does it mean to interact, right? These two components never interact, and it's like you never needed to... Okay, so... we can iterate the size of the first component. Then we can count the number of ways to string together such components like so. Non-disjoint components. Then we add one to the very end. Yeah. Dude, I'm gonna need like 5 DP tables. What the hell? Okay. Think this through. This could work, but think this through. So these components are not going to be disjoint because we're taking one of you and we're sliding you across, and all of you are being interacted with. We need to like convolve you, right? Yeah. Okay. Okay. So PL DP 505 PL dist. Okay. PL PLA PLB. A.F. Okay. We'll use Barrett reduction if we need to, but we shouldn't need to, right? Should be fine. A little mod. Okay, so C end M to mod. So dp1 is equal to 1, 0. Now, actually, yeah, we don't need, okay, yes. For li is 2, let's go to n, I plus plus. So for allow j is equal to 1, j is less than I, j plus plus, dis I is equal to dis j for k is equal to 1, k, let's go to n, k plus plus. St plus equals I minus k. PO cur is equal to 1, 0. Cur equals cur times, so what are you? So you're dpk times dis I minus k minus 1. Cur equals cur times PO. Fine. PO count 1 sum SD. Cur is equal to cur times 2, 0. dp I is dp I plus cur. Okay. See if it works for 2. Awesome. Okay, 2 and 2. So we can do you. Yeah. Okay. Okay. Count 0, 0 is equal to 1. For li is 0, 1, let's go to n plus plus. J is 0, j is less than equal to I, j plus plus. K is 1. Take empty. F is equal to F plus count I minus 1 j mod mod. f is equal to f plus count I minus k, j minus k, mod mod. Times dp k dot f mod mod. F is equal to f times rem is equal to m minus d. If rem is less than 0, break. For lk 0, okay, let's go rem k plus plus. Well, f is equal to, no, so cur is equal to cur plus count ik times count n minus j minus 1 rem minus k. Okay. Ants is equal to ants plus cur times dp d dot s mod mod. Why? You're gonna be 4? 0. Why is 0? That doesn't make sense. What? What do you mean 0? Wait, how? Yes. Yeah, I picked up that habit from screencasting a lot. It's okay. It's fine to rubber duck, I suppose. How are you doing, by the way? I didn't count ij. What's the f? Bro, that's wild. Okay. Ants equal to ants times fact m mod mod. Why? Gen factorial. Damn. Damn it. Okay. I guess we got some work to do. Let's go to Canvas. Nice. There's school. I guess, yeah. I guess winter break is different per place. Or breaks at all, even, yeah. Or actually, I don't even know if it's what is campus. Oh, that's evil. Okay. That's a lot of test cases. 3, 3. I really need the mod, but. Okay, so. Okay, the 620 makes sense. No, we can't do factorial. What are you saying? We can't do factorial. No, that's crazy. Yeah, no, wait, we can. No, we can't. Wait, what are we saying? No, we can't just do factorial. Wait, why not? Because we need ordering too. Shoot. Yeah, we need ordering for multiple components. I wish they gave us a bigger sample, but we're gonna have to do this, huh? No, let's do the brute force. It's gonna make life easier. We're going to okay, so BF and void BF. Okay, so for li0 I is less than m I plus plus for VL for VLX R X dot push back J and R dot push back X. We can do factorial, but we need more. I think we're undercounting. We're like 3 to the 3. That's something's wrong with that. 144 might actually be right. What kind of templating? Like pre-written code? Yeah. Like shortcuts? I use PL and like VL and stuff like that. For both possibilities, yeah. Although I've gotten rid of the F0R for habit of screencasts, and now I've realized it's nice to like actually think about the way loop bounds work. So I got rid of those. But like, yeah, for both of them, yeah. Okay. Let's go down PRR. Perfect. Okay. For for VLXR. For M0, K0, K is less than 2 to the M, K plus plus. The obvious. If not V, xi, vxi is equal to 1. Else, Wait, there's no fact M. What am I saying? You're just 2. No, this is so screwed. I need the brute force. we need to adjust. K is 0 up to 2 to the mk plus plus. Car is 0, f is 1. B is equal to k shift I and 1 if B VP plus plus P. Curve plus equals abs P minus xi. If not, P is okay. So run you 16. Res is 8. Not gonna work, right? Yeah. 176. You should be 1. You'll work. 120, huh? What is this? So it's NTK I J. Why don't you change anything? Okay, we're gonna have some fun. Why does that not change the answer? It used to be 620. JI. Now what do you? JK. Shouldn't make a difference, but okay, so for 2, right? Oh wait, sure. Then we can do 2 sides. Times NCK I minus 1K. Getting closer. Okay. What difficulty range? Like all the entire range, like 800 to 3500. All of them. Okay, we're gonna add on terms until the formula works. That's the plan, right? C into N. Let's try 4-2. Would that be easier to debug? That would work, right? Okay, yeah. So it's 3 that's the problem, of course. So we're doing disjoint. Dis I is dis I plus dis j times dis I minus j times PL and CKIJ 0. PL cur is dpk times dis I minus k minus 1. Cur is cur times PL2 0, right? Because we can do this on either side. dpi is dpi plus cur. There's some screaming going on outside. That's interesting. Dis I is dis I plus dp. Okay, wait. Okay, it's not a distress scream, so that's fine. So I mean 2 works. Count 0, 0 is 1. Alright. So for I is 1 up to n. For j is 0 up to I. Right. So take empty. Or take sum. So count I minus k, j minus k, times dpk dot f mod mod, times nck jk. Count ij is f. Are we forgetting any terms? Yeah, it was consistent too. I don't know what that was. It was a child, but they were like going into their house, so I assume it's fine. For each interval, j minus I plus 1. Rem is m minus d. Oh, mod times nck rem k mod times nck md. Right? That's what we need to do? Beautiful. Okay. 4, 3. We have all the NCKs now. Work. Damn. Now you overcount. Why do you overcount now? Let's try this, right? So you're just completely wrong. Okay. Cool. Why? So this is the smallest case that fails. Count should be equal to dis, right? Dis I is dis I plus dis j. Oh, wait. dpj. Yes. That doesn't change anything? Yes, it doesn't change anything. Let's try 4, 4. What? What do you mean? No, that's not useful yet. So, I mean, how are you both over and under? Please tell me that. Please tell me how you're both over and under. That concerns me. So you work for this, right? Yeah. Fine. Why are you so coherent? Okay, count is now equal to dis. So that makes sense. Well, like count here is equal to this. So that makes sense. So either we're doing them both wrong or neither. Either we're doing them both wrong or they're correct. Well, d is j minus I plus 1. Rem is m minus d. We're undercounting. cur times dpd.s mod times nck md. Wait. No, that's fine. You can be, yeah, you can be less than 0. You can be equal to 0. Count, yeah, count with 0 is always 1. Wait, hang on, what? How are you 288? That perplexes. Oh, because it's 4-3. With 4-4, it should be big. Yeah. With 4-3, though, now we have that factor of other things. So we can have size 3. Then you'll be all of them. We'll have the ways to form that component. Or we could have size 2. We could have something over here. Or we could have size 1. Count is initially 0. Is our brute force correct? Wait, what? Okay, screw it. Wait, so our brute force is wrong? Okay, that's great. Well, that's stupid. That's really dumb. How the hell? Okay. 1388. That's fine. Let's try 500. Are you serious? Are you serious? Okay. Bro, what the hell? What do you mean the brute force is wrong? Alright, fine. Alright, we're done. GG's. I don't know. Okay, that's sad. That's sad that I wrote the brute force wrong. I'm glad I decided to test on that sample, because Jesus. So did you not solve your problem yet? You have TLE? Bro, how the hell did I write the brute force wrong? Okay, generate all the things, right? Cur is 0, f is 1, VL, VN. For each guy, for I is 0 up to n, for I is 0 up to m, VL and R. For J is 0 up to n, for VL, X, R. For I is 0 up to m, if not VXI, VXI is 1. Else, oh my god. I see. I see the issue. I see the issue. Yep. That is indeed the issue. We wrote the brute force wrong. That's such an F. That's such an F. That's such an F, bro. God damn. All right. Well, what can you do? Don't be an idiot next time. Cool. Not a bad problem though overall. Just a combo task, I suppose. So like I can handle 3,000 combo. I just can't handle 3,400 combo. It's just there's such a distinct difference. I don't know. It's just weird. All right. Assume E is impossible. Yeah. That's a flat 3,500. D and E. Just D and E. Like, bro, why? Are you LGM now? No. What? What? Like, what? What? Why? Why do that? Okay, whatever. Anton with the... Yeah. How do people do on this one? Oh yeah, this was the FST one, right? And then the binary table one. Okay, cool. No time issues, which is cool. Even though, even though there was n equals 500 and cubed with a lot of mods, with non-constant mod. Still fine, so that's cool. Is this guy LGM or not LGM? Not LGM, okay. Sure. Alright, so this one I've already looked at. E is 3,500, F is geometry, and I don't really want to do it. So we'll leave it. Okay. U I haven't looked at. U I have looked at, but it's div1E, right? Finding the vertex. With no with no solves. All right, let's go. You have I looked at you? I have not looked at you. Okay, we'll save that. Raif. Round I got IGM on. That's 3,500, right? Yeah. Global round 11. We'll try. Do we try F? No, we don't. Do we? Do we though? Do we? Like, do we? How many? Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. It's gonna be 3,400. It's gonna be 3,400, dude. No, we don't need to do 3,400. That's okay. We'll get by without that. Bubble cup, yeah. Codeforces. This one, I remember H has some like flow theorem thing that I don't know, so I probably can't do it. Yeah, and it's hard anyway. Okay, that's fine. But like, yeah, no, I remember this is a matching thing that people were talking about. I just don't know that. 673. Do you have solves? Both of these has solves. Let's look at both of them. Okay, sure. So I had to play around with arrays and came up with the following problem. Oh, there was hello. That was this morning, right? No, it's tomorrow. Okay. Please don't tell me about that round, by the way. I want to save it for virtuals. I've given up on a few of them. I don't like looking at editorials, so I just tend not to. But I've given up on. I think there's one that I took seriously that I gave up on that I haven't looked at again yet so far. That was from the first day. Decide to play around with arrays and came up with the following problem. You're given an array A, which consists of n positive integers. The array is enumerated 1 through n. You execute the following procedure exactly once. Create a new array B, which consists of 2n positive integers. Merge consecutive equal numbers in B. Find and print the minimum possible value of B, which can be achieved at the end of the procedure. Two, 2, 2, 2, 2, 2, 3, 3, 2, 3. 2, 2, 4, 4, 2, 4. Okay, that's a shame. Okay, so this isn't easy, unfortunately. So, I mean, there is an obvious DP, right? Well, the question is, what do we make the first element? Once we decide what to do with the first element, then what? Then it's pretty clear, right? Either we once we decide what to do with the first element, it's pretty clear, right? Like, (5e5), by the way. 2 seconds, 5e5. This has 6 seconds and 10 to the 5th. And it's freaking, it's probably n root n or something stupid. I have no idea, but I haven't even read the problem. Both of these have around the same rating, right? F actually has more solves. So let's read F as well. Another dull quarantine day is going by when BT Hero decided to start researching matrices of size m by m. The cost of the cell, which is a single positive integer, the direction of the cell. Let's call cell I2J2 reachable from I1J1 if starting from I1J1. Sooner or later visit. Quickly computing the new matrix, BT Hero immediately sent it to his friends. However, he did not save any of the initial matrices. No transition pointed outside of the matrix. You're all positive. Okay, so this actually seems more approachable than, yeah, good night. and soon I will be alone. Because freaking time zones. This seems more approachable than E, actually. Let's look at it. So consider the minimum value. Right. Okay, so if I point to something smaller than me, let's just make you do that. Problem is equal elements. If there were no equal elements, well, it'd always be impossible, but this seems like a flow problem. But it's not necessarily, right? Because this could be very weird. This could be very, very weird. Like, this could be very weird. What would happen here? Not necessarily a flow problem, right? First matrix should be the cost matrix, and the second matrix should be the direction matrix. You could have just like a chunk, right? And there's no like domino tiling. So I mean, basically, each group of equal elements is independent. So we consider a component of sevens, for example, right? If you're a single cell, and you point to something smaller than you, then we can just do that. No, but this is really weird. This is really weird. So if it were not, like we could have some odd cycles going on. Which, yeah, if you were not positive, life would be so easy. Like if you were not positive, life would be so easy, so unbelievably easy. No, it wouldn't. No, not necessarily, right? No, well, yes, no, yes, no, yes, no, no, yes, no. Yes? If you are not positive, then what happens? Yeah, if you can't point anything out. Okay, so we really just need to like handle equal elements. Wait. Observation time? Oh. Yeah. Every cycle has even length. Every cycle has even length. That is a fact. Every cycle has even length because we have to go from, we change chessboard colors every time. And we have to start somewhere and end somewhere. And we have to start and end on the same color. So every cycle has even length. I just kind of thought, like, wouldn't it be cool if every cycle had even length? Because then we could do bipartite matching. And then, like, damn, it's true, bro. That's crazy. That's problem solving for you. Wouldn't it be nice? Oh, wait, yeah, it is, you know? That's cool. So then this problem is solved, right? That's it. So all we need to do then is find an output of matching. Except it's not bipartite exactly, right? Well, it can be. No, it can totally be bipartite. Wait, what is Dinnick's complexity? It's like a little bit of a weird matching, right? No, it's not. It's not. It's freaking not. You're wrong. Unit capacity. Min v to the 2/3 e to the 1/2. Oh. Oh. Okay. So E is okay. Problem solved. Let's go. We need Dinnick and we need to restore the matching. Wouldn't it be cool if every cycle had even length? Wouldn't it be cool, man? Wouldn't it be so cool? Okay. So how does edge matching work, right? Like we need matching for so we do chessboard, right? And we say that every even cell can send flow to every odd cell if they're the same. Every odd cell can receive at most one flow. Every even cell can send at most one flow. Every edge can handle at most one flow. That doesn't matter. And further, if you have an edge to a smaller cell, then you're allowed to do that. Okay, so all we need to do is reconstruct the graph, right? So there are multi-tests for whatever reason. That's actually a pain. Do you need to? Yeah, you do. Damn. That's actually a really big pain. What do we do with n? What is lev? Where is lev set? Okay, so BFS. Okay, so lev is reset, cur is reset. So all we need to do then is, okay, so you're up to 10 to the 5th. Wouldn't it be cool if every cycle had even length? That's how observations happen. That's how it happens, bro. Oh my god. Okay, we're doing this and then we're doing Coder. Dinic 100,005 DC. Okay, so C and M. 4Li0 I is less than N I plus plus 4Lj0 VLG. Okay. Okay, so C and Gij. Okay. 4Li0 I is less than N I plus plus 4Lj0 J is less than M J plus plus. Yeah, I'm focused on the stream, clearly. Okay. LS equal to N times M. 4I0 I plus S plus 2 I plus plus DC dot edge I dot clear. Okay, we'll do it this way. So if I plus j 2 is 0. Else no. Bool valid LR LC return R is greater than 0. I have yet to screw this up, by the way, writing valid, but I'm going to eventually. It's going to be so painful. Const LDR4 is 0, 0, -1. No, we need to. Yeah, okay. Let's do LRUD const LLDC4 is equal to -1, 1, 0, 0. Okay, so for LD is 0, D is less than 4, D plus plus, LR is I plus DRD, CJ plus DCD, LID, RLC, return R times M plus C. Why? Din. I don't know, man. Do I need an init? No, I just call max flow. If valid RC and GIJ is GRC. No. If GIJ is equal to else if GIJ is greater than GRC. Bool F is equal to 0. F is equal to 1. Okay, so D dot add edge, din dot add edge from ID IJ to ID RC with capacity 0 and R cap 0. If F din dot add edge. So if F, you can send flow directly to the sink. T is equal to S plus 1. Din dot add edge, ID IJ, T 1 0. Bool F is equal to 0. Okay, so if F, add an edge. If F, you're a receiver, so you can receive flow directly from SIDIJ 1 0. Okay. Vector VL res equal to G, or it is equal to G. Const car dir for. Okay, so for each of you, N VLM -1. Okay. I plus J. Odd 2 0. What am I doing? Okay, so okay, so Okay, so if let's just do this for now, right? For auto e din.add e.2 e.flow. It's an array, you idiot. ij. Now, d.maxFlow s plus 2 st. Din. Come on, bro. Focus. Why? Because I didn't, yeah. din.addEdge id s id ij 10. din.addEdge id ij t 10. Cool. What? Oh, yes. Okay, perfect. So so if e dot flow is equal to 1, e dot two is equal to t prij. Right. I is 0, 0. I is 2. Yes. Okay. For auto e -1. 0, 0, 0, 1, 1, 1, 2, 1. Perfect. Okay. Now, for LD break, for LD is 0. Valid RC and GIJ is greater than GRC. res I j is equal to gij minus grc. Ord ij is equal to dir d. Break. Okay. And this can actually be the exact same code. Valid RC and gij. Okay, now you work for half of you, right? 1, 1, 1, 1, 1, 2. Yep. Okay. Now if e dot auto RC is equal to decomp e dot 2. Dec. Res ij is 1. Res RC. Res RC is equal to gij minus 1. Ord ij is equal to if R is equal to R and CC is equal to C. Ord ij is equal to dir d. Ord RC is equal to dir d XOR 1. Break. Okay. Bool pause equal to 1. What? You work, right? You're gonna... Yeah. VOV res LX V CLX. Car CV. You work. Nice. Okay. RL RD RD R. You're 1. DU. Yeah, okay. Let's try. So C into end M, vector VLG, N VLM, C into GIJ, LS is NM, T is S plus 1, for I up to S plus 2, din.agi.clear. Yeah. And there's nothing else to clear, right? Ag size. Int lev size. Cur, right? So like nothing else is being used. ID over M, ID mod M. R times N plus C, yeah. So if I plus J mod 2 is 0. So if you have a smaller thing, din.addEdge, id ij, idrc. Yeah. If f, you can send flow directly to the end, and then you can get flow directly from the source. Otherwise, if f, you can get flow directly from the source, and then you can add edge. This might TLE, which would be a shame, but we'll see. Vector VL res n VL m -1, or it is g. We're not using r, but so for I up to n, for j up to m, actually, no, we're not using r. Wait, does this actually work? I'm kind of concerned now. Wait, this might actually not work. Wait, here's the issue. Yeah, wait, okay. Slight issue here is that, yeah. I 0 up to n, j 0 up to m. I feel like this could work with a modification, but I might actually just be wrong here. I think I'm like fairly wrong. So valid rj and gij is greater than grc. Res ij is gij minus grc. Ord ij is dir d. E dot flow is 1. Auto rc is dec e dot 2. Yeah, this is fine. Auto e din dot adj id ij. E dot flow is -1 and e dot 2 is s. D is 0, D is less than 4, D plus plus. Yeah. No, this could actually be wrong. Yeah. Shoot. Okay, I should have thought this through more. Cool, how does this work then? Do we need a different formulation or a different strategy? How does this work? So we might rather... Yeah, here's the issue, right? It says 3, 1, 1, 3. Yeah. No, wait, that's wrong anyway. It's 2, 2, 3. Wait, no, it's 3, 3, 2, 2. Yeah. So we want to... What do we want to do? We want taking an edge to be worth 2 somehow. Like, Like we want to match as many nodes as possible. And you could arbitrarily decide to actually, yeah, then the flow algorithm would greedily take as many of you as possible. And then screw you over. It's almost a matching. Damn, it's a matching? Okay, this is complicated. This is worse than I thought. It's a matching, but some of the nodes don't need to be matched, right? Is it almost correct? Is it almost correct? No, right? Like we could be left with really bad shapes. Yeah, like so. We could be left with really bad shapes. Why did I think this would work? I don't know why I thought that would work. Is it still flow? Is it still matching? Might actually not be. I'm not even sure. I mean, it would have to be something like that, right? This feels very standard. This feels like it should be very standard, but I'm not seeing it. We need to move you down. We need to have you point down. You need to... Well, this isn't going to work. This clearly is not going to work. So we need to do something else. What is that something else? Flow problems easier on the thinking side? No, definitely not. Yeah, flow can get very, very hard. Flow can get very, very hard indeed. As I speak, I just got a formulation wrong, so that's cool. How does this work? Perfect matching. So we need a perfect matching, but only some of the nodes need to be matched. So it doesn't actually need to be a perfect matching. It just needs to be a close enough matching. You know? There's also a grid matching, which matters. We could exploit the grid thing. I mean, yeah, it's not an arbitrary flow network. It's not an arbitrary matching problem. It's a grid matching. Right, so how does this work? We need a grid matching. We need to move you down. matching, but some nodes are allowed to not be part of the matching. That's our formulation. Matching, but some nodes are allowed to not be part of it, right? Matching, but some nodes are allowed to not be part of it. Oh. Wait. Oh no. Well. Can we do min cost? Yeah, we can do min cost, right? Okay, I'm so rusty with flow algorithms. Holy Christ. Min cost exists, and that means that we'd rather send flow using the edges than not. Does that work? Does that work? Does it work? Does it actually work? Yeah, okay. I kind of have faith in that idea. We need like, okay, all right. But this is slow, isn't it? Are you fast or slow? Like, what's the complexity, man? What's the freaking complexity? Approximately e squared. But I know they're fast, I know they're fast templates. I know Ben Q's is n squared. Sorry. Yeah. Damn, this is kind of rough. Hello, what's up? I am having a good time on a flow problem. Okay, but just give me the freaking code. I don't care. Aye. Are you? No. What does strongly polynomial mean? Let's see how fast this is. Sure. Let's move you here. You are that, which we don't need anymore. Okay, if you don't TLE, I'll trust you. Oh wait, yes, we need the BenQ version. Yeah, this. Okay, din dot init s+2. Why? Are you gonna scram me? Yes. Okay, you're fine. What do you mean cin is? Okay, cap cost. So 129. Calc. You still work, right? You don't compile. Seg fault. What does that mean? What do you mean seg fault? Where? Like where, man? Oh wait, you're here. Okay. You make it here. You're just weird. Make it here? I don't understand. No, EDF flow is 1. Else. I see. 4i 0 is now plus plus. Pi is equal to dist I plus 0. Okay, let's do this. Let's be smart. Thank you. Okay, are you gonna work? Oh yeah. Sure. Okay, that's fine. Okay, now we just need you to not be freaking n squared. Okay, so we don't have negative costs, which means we can use Dijkstra to be fast. All right? Do we need this? Wait. Do we need this either? Let's just This is really dumb, but let's try this. It shouldn't wrong answer. It should at least be correct. I've never had a fast min cost template, so this is actually good. Yeah, TLE. You're just really slow. Are you just being Codeforces? Feels like it's gonna TLE. Yeah. Okay, so why does that happen? Okay, so min cost seems correct. Let's hope it passes 7 tests, but it's not fast. Okay, so we need to look at the complexity for Cactal, because I know there are min cost templates that like work for 1E5 somehow. I've seen them. I've not seen them, but I've like. I mean, this clearly doesn't work. Fast min cost float Codeforces. Okay, maybe this just doesn't work. Min cost can't be that fast, can it? I don't know. I mean, there's a. Does this actually apply? Okay, this is not. None of this is practical, but. I just want to know how fast it gets, man. Wait, is this do min cost or not? Okay. So you're something squared, right? That's the problem. Oh, 1. Yeah, you're something squared. You're a Taily. Oh, even worse than n squared. Okay. Yikes. Does anyone here happen to know about min cost flow? I feel. I swear I've heard of. I swear I've heard of like fast, like it working for 1E5 somehow. I swear I've heard of that. I mean, I guess there's a way to do this without it, but 6 seconds though, right? Like it's gotta be. Nice. Accoder library, that's true. Okay. Damn. Do I have Accoder in here? I do, right? Or is that the old computer? Damn. I swear I did this before. I love research, man. Okay, let's just... okay, so BenQ is not going to work probably, right? I swear that was fast min cost. God, are you serious? How? Okay. This we can do. You better? What a G. I'm sorry, what? Oh, okay. Okay, so how does this work? Okay, so MCF graph. Flow. Okay, let's just get rid of this for now. Let's see how fast you are. Are you serious? You're gonna be that. You're just gonna be a little bit too slow. One sec. Okay, well, this is faster, but it's still too slow. It probably wouldn't do anything, right? Yeah, it actually does. Okay, well, still too slow. Really? Damn, okay. Alright, this isn't gonna work. This isn't going to work, is it? Oh, that screws up the capacity, right. Okay, I see. Yeah, so this is problematic. Could have sworn. Oh, we could do this. we could do library checker. I forgot about that. Graph. And cost B flow. What is B? What? Is this more general? Oh, this is useful. What does this do, though? Like, what is this? It's actually useful. Why is Yosupu always like this? It's like this doesn't work. Okay, I guess what I'm looking for doesn't exist. I could have sworn this was possible. I could have sworn I've seen it, I mean. What does this do? Okay, this isn't gonna work. So, I guess this is too slow. We're gonna need a new solution for this. So min cost is not fast. Min cost is not fast. Hello. Min cost is not fast. Min cost is just not fast. But it does seem correct. So it's like something. I don't like. I don't see it. Alright, I think we'll do the accoder and then we'll come back to this. Or maybe, I don't know, we'll see. See what we do with this problem, I don't know. I want to do the accoder right now. I'll be back in a bit. Okay. Let's do this. So we're gonna get rid of all of this. I'm just gonna do something more reasonable. Okay, so let's do this. Yeah, 165, right? We're not doing this. We're not doing that. Yeah, this one looks hard. Okay, interesting. Go. So, yep. Got it. Cool. Um, so we have a bunch of prime factors. Oh, we can have ones. Okay, then it's just prime powers are less than or equal to n. Okay, yeah. Okay, sure. Number theory. Gem primes will be 5. Four. Multi-tests. is equal to v pos 0. C to n, VLF is factors n, map LLC, LXF plus C of x, pos is 1, V is n for auto x, y, c, R is 1. So if R is v, pos is 0. So if n is a prime power, we're screwed. Okay. That's kind of fun. Okay, sliding window sort 2. So B and C are same difficulty. Cool. Damn, all right. I'm getting a permutation P, choose an integer I, and sort PI to, okay. Final lexical graph, the largest permutation that can be obtained by performing the above operation on P exactly once. I want to do the least damage, right? Okay, let's read C. Social distance on graph. There's a simple connected undirected graph with n vertices numbered 1 to n. Graph has m weighted edges. The ith edge connects vertices ai and bi with a weight of wi. For any simple path connecting two different vertices painted in the same color, the weight of the simple path is at least x. One and 3 red and vertex 2 blue. So consider each edge. This looks more appealing than B. Consider each edge, right? If you're going to go consider each edge. And consider any triple of vertices. If you're not adjacent, we don't care. Consider each vertex, right? Consider the color you're painted in. Okay, it's binary search on X. binary search on X for any edge strictly smaller than X. We say that you must be different colors. For any edge bigger than X, we don't care. For any edge strictly smaller than X, we say you must be different colors. Now, consider any path of length at least 3, right? Yeah, so we only care about paths of length at most 2. So any small edge will have an, okay, this works. There's at least 3. Yeah, you're connected. Okay. No. Yeah. Okay, so bool this 200,005, call 200,005. If call I is equal to call X and W is less than M, pos is equal to 0. sort ct.begin, ct.end, c.size, pause and equals ct0 plus ct1 is greater than equal to m. If pause l is equal to m plus 1, else r is equal to m. Multi-tests. Where is 6 coming from? It's 2, 9. Three, 4. Right? No, 2, 3. Call I. Sorry, what? PRIXW. What? Wait, why? So what is small just? It's just 3, 5, 1, 8, 34, 1, 9. Not this I, DFS I am. Yeah. Yeah, it's kind of necessary, isn't it? 66593. What? Let's do this. Stop being stupid. Okay. Yeah, we're being dumb. Okay, yeah. Void DFS LV LM. If visv return, visv is 1. Auto xw HV. If w is less than m and not visx, prvx, yeah. prmi call I. So if call I is equal to call x, yeah, pause is 0. Okay, sure. Sliding window sort 2. You're given a permutation P. Yes. 31425. Cool. Okay, that scared me. That scared me, but okay, cool. I mean, yeah, it's n log squared, so it's like gonna be slow, but come on, man. Cool. Okay, we're not doing that bad. Solves on E. Damn. Okay, well, E, yeah, E and, okay, yeah, so what the hell? Let's consider the sorted prefix and suffix. Consider the operation we do. You're going to sort some range. And it's going to set the beginning to the minimum of that range, right? And it's going to sort some set of ranges, some disjoint set of ranges. So if we have any sorted subrange, we're good. We look at the prefix that's sorted and the suffix that's sorted, right? And then we want to look at the prefix that's sorted and the suffix that's sorted. So obviously, we want the range with the smallest L. If you have a bigger L, so we want the range with the biggest L. If you have a bigger L, we want the range with the biggest L. If you have a bigger L, then you're going to be screwed, right? So then of the ranges with the biggest L, we want the one with the smallest R. Okay. We'll probably stress test this one because it's really easy to stress test. BL brute. So BLR bool F is equal to 0. What? Max. Also, what? How? Oh my god. Plus I beta end plus I plus k. Begin, you idiot. Bro, come on. Focus. Focus, man. Nine, 4, 3, 1, 11, 12, 13, 15, 17, 7, 2, 5, 6, 8, 18, 19, 20. Okay. If local jur is equal to brute A. Res equal to smart A. Okay, so what we need to do then is LC and RC n. If AI if I is equal to 1, I is less than k minus 1, I plus plus. K is 1, k is 3. We'll go 1, and then we'll do 2 here. RCI minus k minus 1 equal to C. Crap. Okay, so we're starting at I. We're starting at n minus k, right? Okay. We'll just if k is equal to 1, return a. Let's just do that. Well, C is 0. I equals 1, I is less than k minus 1, I plus plus. Okay, so we're going down from n minus 2 to n minus k. If AI is less than AI plus 1. Okay, yes, I know, but so for 3, right, you have 0, you have 1. Wait, no, that's not right. Wait, that's not right at all. No, that's not right. We need you to be the minimum. So we need the first element to be the minimum. And the second element to be the second minimum, and so on. How do we do that? Okay, here's what we're doing. So we need you to be the maximum. If AI is greater than AI is less than st.begin. you should be the same. Don't even consider you. Okay, so RC is 345. 3450. 0, 0, 0, 1, 0, and then zeros for the rest. LC is 0, 1, 2, 3, 0, zeros for the rest, then 1, then yeah, okay, sure. Perfect. Okay. PL best equal to 0, negative 1, n. LL LCI is equal to K, return A. L is equal to I plus LCI, R is equal to I plus K minus 1 minus RCI. If L is greater than best.f, best equal to L, else if L is equal to best.f, if R is less than best.s, best is equal to LR. Sort A.begin plus best.f. Best.s plus 1. Cool. Okay, stop printing so much. Okay. Why? Why? Okay. 2, 5, 6, 8, 18, 19, 20, 16, 14, 10. Yeah. Okay. Seven, 4, 5, 3, 6, 1, 2. Wait, what? Wait, why? Three, 7, 2, 1. Why is RCI 2? I equals 2. Oh, why? 3, 5, 6, 4, 2, 1, 7. Oh, come on, Mom. Why? Erase. Bro. Okay. N equals 4, K equals 5. And 3, 5, 6, 7. Wait, what the hell? For LI is n minus 2. I is greater than n minus k. I minus minus. If AI is less than star is teed up again. Oh, the minimum changes. Oh. Oh, the minimum changes. Indeed it does. Okay. Fine. AI. Why is my computer lagging exactly? I need min and max. Okay. If AV less than M, L is equal to V plus 1, else R is equal to V. LCI is equal to L. if a I plus k three, 5. One, 5, 7, 4, 3. Wait, what are you even doing? Oh, it's because you're screwed up. LCI is 2, right? I plus. Okay, y 1, 3, 7, 4. Come on, why? Oh, good. Okay. Run scene to end decay. Cool. Finally. All right. Substring comparison. Integer sequence x, let XLR denote the integer sequence XL. Okay. That took a while. Damn. Fourteen 11. Integer sequence x, let XLR denote the integer sequence XL to XR. XAIBI is lexicographically smaller than XCIDI. Okay. The tree with n vertices numbered 1 to n. The ith edge connects vertices AI and BI. Tree with n vertices numbered 1 to n. So each connected component of the graph has k or fewer vertices. Choose one uniformly at random. Belongs to a connected component with k minus 1 or more vertices. Delete all edges with the chosen vertex as an endpoint. Interesting. Interesting. First operation chooses vertex 2, deletes all edges. Each connected component has not more than 2 vertices. Okay, both of these look hard. Cool. XLR, not the integer sequence. XAIBI is lexicographically smaller than XCIDI. Okay, so something, right? Something. Kind of like Emor. Vertex 2 deletes all edges after which each connected component. 1, 2, 2, 3, 2, 4. So in the process is useless. If we do linearity, then I'm interested in So I'm interested in so what is the probability that this vertex is part of an operation? F is impossible, right? Yeah. Mm-hmm. Mm-hmm. Okay, why are we reading this? Stop it. XAIBI. So when we get the tree at this vertex, focusing on this vertex, we're interested in the probability of getting to a state where we have this many vertices. Noting that we don't care about smaller operations. It's like operations and other components are irrelevant. So our operations are going to be in chronological order. Pick a vertex, remove it. Pick a vertex, remove it. Pick a vertex from this component, remove it. Coding, man. Pick a vertex, remove it. So what's the probability of this happening? We only care about stuff in this component. We could like have a snake tree and then like walk up it, right? That could happen. And for all states, it's just the sum of that. Each connected component has not more than 2 vertices, so we finish performing the operation. On the other hand, if the first operation chooses vertex 1, it will still be a connected component. So we have probability 1/4 of that. Probability of having a state where k is not removed. What's the probability of having a state where k is not removed? And we have this many vertices. Obviously, that's not enough information. But if we could do something with the subtrees, right? So if we have operation sequence this, and then operation sequence this, if we have operation sequence this and operation sequence this, then what? What do we do with this operation sequence then? What do we do with this operation sequence? So we can delete these. Do some fancy merge. So we could have this many operations done. To remove this many. Have this many operations done to remove this many. And we can alternate, right? Probability of having this happen. So assuming we do this only after. Okay. The only thing we need at this moment is the number of vertices in the rest of the component. We absolutely need that. We need the number of vertices in the rest of the component at this moment. It must be strictly decreasing. It must be strictly less than the number of vertices here. This is better, but it's not that much better. I need to decrease U. What are the solve counts? Does D have like way more? D has many more. Okay, I guess we'll look at it. Yeah, fine. So integer sequence X. And quadruples of integers. AI just, yeah. XAI BI is lexicographically smaller than XCI DI. So I mean, we'll allow for equality. One, three, three, four. 4, 4, 1, 2. Let's consider all the forward-facing ones, right? So if we have one, let's consider all the forward-facing ones first. Consider all the forward-facing ones first. 1, 3, 3, 4, right? You can... So if you start at the same point, so if you start at the same point, okay, let's see. So if this one's longer than this one, right? Then we're allowed for you all to be equal. Equality is good, right? If the whole sequence were equal, every condition. Let's start with the whole sequence being equal. If we have any two that start at the same point, okay, wait, so first consider the ones that start at the same point that they... So if you're longer, you're not going to be lexicographically less. Otherwise, we ignore you. Okay. Now we consider the ones that go... Consider the ones that go further back, right? Now, how would we not construct a sequence? Okay, so we make all the intervals the same length. I say some of them are less than or equal, and some of them are less than. So we have some less than or equal conditions and some less than. And for these, if you're longer, right? Okay. So for these, if you're longer, OBS recording, right? Yeah. For these, if you're longer, so we have this and then we have this, right? So you must be lexicographically less than this. So this must be less than or equal to this. So this must be strictly greater. No, greater than or equal to, right? Yeah, greater than or equal to. We're not inversing the condition. Wait, are we? Wait, what are we doing? No, we're just flipping it. If 1 must be less than or equal to 1. Yeah, we're not inverting it. We're just swapping the order. So if A must be less than or equal to B, then B must be greater than or equal to A. That's how it works. Yes. Okay, cool. Now we say, okay, we look at you. If we have so we have less, not less, equal, not equal. Or less, not less, greater, not greater. So we consider all of these intervals. Okay, we group together by distance apart, right? Because otherwise we don't care how these elements compare, pretty much. We almost don't care. Do we care? We kind of care, but not exactly, right? Well, we kind of care, yeah. No, we do still care. It's just less? I don't know. Why is the sample like this? We do still kind of care. One, three, three, four. Less than or equal to and greater than or equal to. So consider all the ones with you. Right, then we say, okay. Consider all the ones at distance 3 apart. consider like the tightest condition, right? We'll make you this. Make you as far out as possible, right? Make you as far out as possible. If we do it this way. If we do it this way, right? We'll make you as early as possible. Because why not? Might as well. If we have both a less and a greater, so we can assign these constraints. So if you're allowed to be equal, right? Do we want you to be equal? This seems so messy. If you're allowed to be equal, do we want you to be equal? Move you, move you. Right. So say you must be strictly less than, right? So we have no constraint to the left of this. Suppose you must be strictly less than. And then suppose this must be less than or equal. Suppose this must be strictly less than. And suppose this must be less than or equal. If you must be strictly less than, right? If we have a strictly less than and a strictly greater than, like anywhere at all in that position, then we contradict. At any point, then we have a contradiction. Otherwise, if we have less than and greater than or equal to, so if we have less than and less than or equal to, less than is here, less than or equal to is here. Then we can ignore you. And we can ignore you. So if we have less than or equal to, we have less than, right? And then we have less than or equal to. So for the less than, we're going to have a point of equality, and then we're going to have this. We have less than, or we have less than or equal to. And we're going to have this. Yeah, so we can drop the less than or equal to. So we have less than and less than or equal to starting at the same point. We can drop the less than or equal to. If we have less than and greater than, then we're screwed. Then it's a contradiction. We have less than and greater than or equal to. Then the less than must be longer. The less than is shorter, contradiction. Otherwise, the less than must be longer. At which point we can then say these must be equal. Consider the shortest less than and the longest greater than or equal to. We can say you must be equal, and the rest of these less thans can move. Furthermore, the shortest less than is all that matters in that case. What do we do from here, man? What do we do from here? Can we force some constraints? We have less than and then less than or equal to. We have less than and then less than or equal to. Less than and then less than or equal to. What is going on? So here we have a greater than and we have a less than equal to. The greater than is shorter. No, greater than and less than. Integers and quadruples of integers. Ay. Sequence, excellent, excellent, or not the integer sequence. the things that are forced to be equal? There's certain things that are forced to be equal. If there was no less than or equal to, if there was no less than or equal to, yeah, if, damn. If there was no less than or equal to, then we'd have an interval of greater than. Less than or equal to. Damn, man. I don't know how to do this. I don't know how to do this. I don't know why I'm psyching myself out, dude. Sequence X. Still on the grind, yeah, but not not doing so hot. This contest. Yeah, I don't know, man. I don't know what's with this. Oh. No, wait. No, yeah, never mind. Yeah, what am I saying? One third, 1/5. 1/10, 1/9, 1/7. 1/10, 1/8, 1/7. You can't just do that. Okay, well, we're not solving either of these. I'm kind of tired of this contest. Let's leave it. Come back and check out the performance later. See if we can figure this one out. So can we actually flow this or not? And we just need to solve that part. Okay, so what do we do with the tiling? So we want to initially let this happen. What do we do with the tiling? Are we doing fireworks now? I don't know what that was. So, like, what do we do with the tiling? So min cost would work. Can we make it a matching without actually having it be min cost? Can you not? Can you freaking not? Min cost max matching. Blah. Okay. Cost this so. Can I like... Let's do this. Let's make a special case here. That's obviously not going to work. Okay, so min cost is not going to work. Sooner or later, visit I2, J2. What do we even like? What do we even want to formulate it as? I want you to be the minimum possible edge. I want to find find a set of pairings such that you work. You define a pairing. Find a pairing such that you work. Given a grid, we need to find a pairing such that you work. Min cost is n squared. Well, that's great. Find a pairing that works. I muted my mic, right? Yes. We have to find a pairing that works. 7, 6, 7, 8. So that's easy. Component is odd side. No, that's not the issue. The issue is that it could arbitrarily decide to do this instead of that. Can we patch it together? Cool. I love fireworks, man. So I mean, it could leave some cell unfilled, like in the middle. Like, it could just screw us over like that. It could leave some cell unfilled in the middle. Oh god, dude, I feel like this has to be known. That's stupid. Yeah, fine. I don't understand. Some are allowed, some are not. Should we do it with demands? Please. Please give me something. Are you? Ugh. Okay. Do you have? Okay, but stop. Max flow edge demands. Okay, but are you fast? Let's try this. Sure. Dinic. Edge I dot clear. How many freaking times do I have to? How fast are you? Max flow edge demands. Din done it as opposed to solve. Ugh. Ni. What? Okay, bro, just where? Where are you? Okay, this is stupid. ICPC team, no, please. Just okay, graph. Max flow dynamic. Thank you. Thank you. Okay. Why are you? Okay. Max flow dynamic. Okay, so you have no demands. Oh. Uh, 1.9. Okay. What do you? What do you actually do? Oh wait, stop. Okay. How fast are you? Oh my god, I finally found a flow with demands template. Holy crap. GIJs, RNG, mod 2. How fast are you? Come on, be fast. Are you actually fast? Oh my god, you're fast. Wait. Wait, no way. Wait, no way. Wait, no way. Wait, no way. Come on. Okay. Okay, how do we... What is the residual? Oh god. All right, come on. How... Okay. Okay, so let's... For auto E, din dot graph PR E dot... What do you say? Res next. Din dot mf dot. Okay. Yes. Okay. Stop. Wait, no way. Wait, does this actually work? Dude, I've been looking for a flow with demands template forever, man. Forever. And this existed 7 years ago? Are you kidding me? Okay, dot res is 0. Okay, so if e dot res is 1, next. Okay, good. Okay. Alright, do the same thing. If res ij is equal to -1, for d is 0, d is 4, d plus plus, r I plus drd, c is j plus dcd, if valid rc and gij is greater than grc, res ij is equal to gij minus grc, ord ij is equal to dir. Damn. Wait, what? So f is 1. Okay, so we have to send flow through you, and we have to send flow through you. Oh, no, wait, yeah. So 1, 1, 1. So you have a demands of 1. Okay, so 1, 0. You have a demands. PR. Wait, do you not produce the reconstruction? Are you serious? Do you actually not produce the reconstruction? Come on, man. Come on. Why is this template so hard to find? Oh my god. Why is this? Okay, but you don't have freaking code. Have done add edge. SE cap minus demands. You really don't. You don't produce the construction. You crash. Why do you crash? What do you mean? What do you mean? What does that mean? Sorry, what? Okay, wait, something is... How do you have float at 25? I equals 0, j equals 2, e dot res is 1, e dot nexus. Something's wrong here. Why do you have flow out? You shouldn't have flow out at all. You shouldn't be getting flow. I'm so confused. I'm so confused by this. I'm so confused. R is 110. Why do you have flow to the source? Oh, what is residual? What does that mean? Why are you using memset on vectors? Okay. Let's try this. How? D. Do you work? If you could just work. Let's try it. Let's try submitting. I don't know if you're fast. Well, yeah, you are fast actually, but are you correct? Are you correct? Work. Okay. Runtime error. Runtime error on test 15. Runtime error on test 15. It's correct, but how high, by the way? How is it runtime erroring? Can you please tell me how you're runtime erroring? Can you please tell me how that's happening? Please. Please. n times m is less than or equal to 10 to the 5th. Can you please tell me how you're runtime erroring? R is greater than equal to 0 and R is less than n, and C is greater than equal to 0 and C is less than m. ID R LOC. Turn R times m plus C. R times m plus C. ID over the number of columns, ID mod the number of columns. Yeah. Dim.init s plus 2. 5 plus j mod 2 is 0. Valid RC if gij is equal to grc. Is greater than grc, f is 1. Din.add edge id ij t1 not f. Vector vlres plr is din.solve st. 5 plus j mod 2 is 1. For auto e din.maxflow.graph id ij. Do I have any asserts? Oh. CC is J plus DCD. If RR is R and CC is C, or ij is dir D, or RC is dir D XOR 1, break. That's my only assert, right? Valid RC and gij is greater than grc. Res ij is gij minus grc. Or ij is dir D. VOV res for LLXV if x is -1, pos is 0. I mean, okay, yeah. So that's my only assert. Okay, void init int underscore n. mf.init m plus 2. PRSE cap demands. mf.add edge. I 0 up to n. If in di, add edge to that. In d.resize n, out d.resize n. Yeah, we're knitting s plus 2. I mean, this we're not touching. So e.res is -1 and e.next is not equal to t. Less than s. How about that? Let's just play very safe. I don't understand why that would change anything, but I don't know, man. He's still gonna run time here? No. What? Okay. Okay. Cool. I found a flow with demands template. Oh, that's awesome, dude. God, I've literally been looking for that for years. Like, not constantly looking, obviously, but like, I've just been like, wouldn't it be cool if we had one? Damn. Okay. Great. 3,300 flows. Let's go. found a flow with demands template. I don't understand why that assertion needed to happen. Why did that assertion need to happen? Status access violation. So it's probably that you had an edge to S somehow. I don't know how that would happen, but there's no way that that would happen. That makes no sense. That makes no sense. If e.res is -1, are you like big or what? Okay, wait. Let's take this code and just run it on a large case, right? 315, 315. Gij is RNG mod. Yeah, sure, big. Okay. So what was the issue? It wasn't the assertion. But why would you have an edge? And e.next is not equal to t. But why would you have an edge to s? There's no reason that you would have an edge to s. Like, the only edges that you would have are 2t and to... What? Why? How? How? Assert... Are you getting corrupted? I don't understand. You're gonna fail the assertion, right? No. If e.next I don't know why I'm doing this on custom invocation, but 0199228. I'm sorry. Oh my god, it's because of the freaking demands. Okay. Everything is understood. Everything is understood. Everything is understood. We solved. Okay, we found flow with demands. I'm very proud of that. Okay, I understand everything. So screw you. This is the best, like, ever. I'm going to bookmark this. I'm gonna put this in my templates, like tonight. Tonight we're gonna fix my templates. We're gonna write the cent, and we're going to write the cent. We're gonna do the marks. Yeah, okay. I'm fixing my templates tonight. Okay. We're fixing my templates. What are you? Yeah. Templates. Write descent. Okay. All right, awesome. We found flow with demands, and we solved something that looked impossible. That is very cool. Apparently, flow with demands is as fast as Dynic, which is actually crazy. That's insane, dude. That is insane. And it was just there. It was just there. Like, where was it? It was just there. It was just one of the GitHubs. Like, it was just there. It was just in a repo. It was just in a repo. Print the amount of flow. Okay. Well, we're just gonna no, we need to star that. Okay. Do we try E? I guess we can try E. I guess we can try E. Dude, when was AG? How long has it been since I've needed this template? It's been like 3 years, right? It's actually been like 3 years since I've discovered what flow demands is, and I haven't been able to find code for it. And it was just there on a repo. It was just there. Like, it was just in a random repo that looked like all the other repos that were like school projects, except this time it was it was freaking n root n flow with demands as fast as normal flow with Dinic, with a Dinic template, with, oh my god, oh, what a amazing, dude. Friggin' amazing. Given array A, which consists of n positive integers, the array is enumerated 1 through n. You execute the following procedure exactly once. Create a new B, which consists of 2n positive integers, where for each the condition B, yeah, we know the problem. I don't, bro. God, okay, sometimes, I will admit, sometimes I do get held back by knowledge. Like that was a freaking knowledge problem. That was the worst. But it's not that often, you know? Like, it's not that often that knowledge matters that much. Wait, did you, sure, send it. I mean, yeah, I mean, I first encountered a flow with demands problem in some, like high school contest that we did like 3 years ago, and I tried to read papers, and I just could not make code work for it. And then it's just there. It's just there. It's just in a repo 7 years ago that just lay unfound. It was a contest for high schoolers. It was like an international thing though. And yeah, I mean other teams solved it. That's the thing. I just like I don't know, man. I don't know. High schoolers are pretty tough. I mean, I was 2600 in high school still. Like, just, yeah, stuff. Okay, I still have adrenaline from that. Oh my god. Okay, I need to cool down and solve this next problem, huh? Okay. Flow with demands. And that problem looked impossible. It didn't, like, I don't know. It's like, if you know it exists, which it took me a long time to just remember that algorithm existed. And then once you do, like, suddenly, like, the fact that you need to send flow through certain nodes, like, that's just obvious. Like, that's clear. I guess it's 3300 because of E being hard. Because, I mean, I don't know, like, that problem felt pretty fine. I guess there's there's that one observation that you need to make, but then the rest is fine. Yeah. Blah. Okay, let's solve split. Set a player with arrays and came up with the following problem. You're given an array A which consists of n positive integers. The array is enumerated 1 through n. Execute the following procedure exactly once. Create a new array B which consists of 2n positive integers, where for each thing the condition holds. Merge consecutive equal numbers in B. 5e5. Okay, so suppose we know what the first element becomes, right? Suppose we know it's going to become like 1, 2 or something, right? Then if you're too big, so like the thing that's stopping us, right? Well, there are two things that would stop us. One, we want equal elements to be a thing, right? We want equal elements to be a thing. And we want, what else? Okay, yeah. No, I don't, never mind. Actually, yeah, the thing I was gonna say, it was not created by high schoolers. It was just for high schoolers, which is still pretty crazy. But yeah, it's like 1% less weird, I suppose. I don't know. People solved it. That was Aragorn did that contest. We were, I think they won. That was fun. Did they? Yeah, they won. We won the qualifier, but they won like the final contest. Okay, so we can add at most 1. Are you all even? No, right? You're not all even. So I mean, equal elements, right? Equal elements what? What equal elements? Equal even elements. There's some like cost is always 1 stuff going on here. Who solved this? Did people solve? Some people solved DNF, right? Some people got both. Yeah. Oh, he did E before D. Of course he did. He's tourist. Why would you not solve E before D? Damn, man. God. Okay, so F actually, like, yeah, F is worth points. Weird runtime errors. So this is like has this become a textbook flow with demands problem? Like this one? Is it even that? Or is it just like, is that just one way to do it? I don't know. Given an array A which consists of n positive integers, array enumerated 1 through n. Yes. So I mean, we have freedom to do whatever the hell we want with 0. Okay, suppose the first element is even, right? You're gonna make a new array. Suppose the first element is even, right? So we have optimal and optimal plus 1, right? That's sort of the thing we're doing. So, okay, so we have a range of numbers that's optimal and a range of numbers that's optimal plus 1. It's kind of like that. Nah, I don't like a problem that I've done before. That's the reference to it. Indeed, it is. Very fun. Very fun indeed. Okay, so optimal plus 2, right? So we could have optimal, right? Optimal plus 2, right? Instead, take optimal and partition it into 2. And you'll have whatever number you want. Yeah, so there's no reason to have optimal plus 2. So we have optimal and optimal plus 1. And what does that constrain us to? So we have k and k plus 1, right? So what we can do is make it exact. Is optimal and optimal plus 1 always going to be an interval? Is that what we're dealing with here? So an optimal will be an interval. Then can we prove it'll always be contiguous? Can we? Let's hope it'll always be contiguous. How about that? Okay, so C and N. Okay, is equal to 0. Vector PL So for if a0 mod 2 is equal to 0, else plus plus k o dot push back 1 a0 minus 1 o dot push back a0 over 2 a0 over 2 o1 dot push back. Why did I do that? Okay. For I is 1, I is less than n, plus plus. If ai.f less than or equal to cur.s max cur.s ai.s, else vector r dot push back cur is equal to ai, r dot push back cur turn r. OT. If x mod 2 at t dot push back xx bool f is equal to t plus not f dot push back x over 2 x over 2. Match LPL is equal to, what do you, so you're x minus r, right? So if we have 1, 3 and you're 5, then you're 2 to 4. x minus r PR 2x minus L. One x minus y. Well, at p dot size is 0 plus k plus p. For auto p o at p plus 1 dot ot is equal to comp at p plus t. Okay. Two zero two y. Okay, so stuff. Why is K3? What? How are you 3 already? So 2, 3. Wait, what? At is this. 3, 3. Wait. It should be 0. Okay. Now x equal RNG mod I don't know, man. I mod 10,000 PR 0 dot size 01 dot size. You probably don't work, right? This probably doesn't work. I don't know, man. screw it. Let's submit. Why not? It's gonna TLE, but I don't care. It's practice. And once it does TLE, we'll find a case. You're going to TLE, right? Yeah, you must TLE. Actually, wait. Why does that work? You're gonna TLE. Don't print A. It's worth a shot. It's worth a shot to submit. It is worth a shot. But of course it's not going to work. Of course that's not going to work. Why would that work? Why does this work? Why does it work so well on random data? What am I missing? Stop. Yeah, you can get big, right? What does it take for you to get big, though? What does it take for you to get big? So you're going to be like single elements, right? Yeah. Wait, what? Yeah. Can this be optimized? This can be optimized, can it? Oh, right. You're gonna be garbage. I do read chat, but not much is going on right now. Sorry, I respond to highs like sporadically and unpredictably. Okay, I don't know how to make this. I don't know how to break this. How did it happen, first of all? It's like we could... We could what? So I have an idea. I do not like this idea. This idea does not make me happy. So if we so and we have segment stuff. So regardless of your size, if we have a thing in opt that gives us middle, then we do that. Otherwise, everything in opt will invert and some things will be trimmed. Everything in opt plus 1 will be eliminated, except for maybe the thing that has the middle. Otherwise, we increase by 1. And we trim both. And that works. But it's a mess, right? Because suddenly we have to do some alternating sum stuff. And somehow we have to do some comparison stuff. I have to, oh my god. So we maintain a set of disjoint segments. So we have some correct n squared log n code, and we have an idea for a stupid n log n. And I have to code it. We're gonna do some dumb things, right? We're gonna end up doing some dumb things. So the hardest part is trimming. given a particular interval, knowing that you started on, say, an odd position, you're going to be well, it's not the worst, right? No, it's pretty bad. It's pretty bad, man. Is it? Wait. Okay, so we maintain a list of disjoint intervals. And we just have to write some interval stuff. We just have to write a whole bunch of interval code. And this would work. It would be n log n. But it would suck. It would suck, right? Yeah. Okay, so we have let's do a brute force, right? So okay, right. Return K. PR dom A. Okay, so you're correct. You passed 12 tests. That's fine. But we need you to be fast, which is really a shame. It's really sad that you need to be fast. Okay, but actually the more I think about this, the less bad it seems. Which is scary. That scares me. That is very scary. Okay, so like, there's the chance that when there's a chance that opt completely stops working, and opt plus 1 stops working, right? Oh. So everything in opt will carry over. If we have something in opt, if opt is non-empty at the beginning of this, right, then we push a new interval, which is saying do that. We assume opt is non-empty. So that's opt plus 2, right? And if nothing in opt works, is it really possible for, it really is possible, huh? It really is possible. So I mean, this could be odd, but the only way we get, yeah, so if we get a new middle, right, then we just completely disregard everything else. If we get it's gonna be impossible to debug. Oh God. Okay, we're gonna have fun with this problem. We're gonna have so much fun. So F is impossible because it's flow demands, and E is intervals. Who doesn't love intervals, right? Ordered pairs of numbers such that the first is less than or equal to the second. Who doesn't love those? Who's just not romantically yeah. Indeed. Who is not? Who is not? I'm not gonna finish that, but yeah. Intervals, right? So think this through, because it's gonna take a while, so think it through. Okay, so we prune. Okay, so if opt has a middle that we keep, then we just do it. If x is even and the middle is part of opt, then we get you for free. So we just keep, we just stay there. Otherwise, there's no way to not get opt plus 1, right? So we can get opt plus 2 for free. We can get opt plus 3 for free. Opt plus 1 is anything from opt that carries over, or the middle from opt plus 1. Opt plus 2 is free, opt plus 3 is free. Okay. Yes. Okay. Okay. So if it's a smart A, if it's a shame that I how do you I don't know how to construct a counter test to this. I can't break my own solution. Well, it has to be that it has to be that you get a bunch of middles, right? So you have to have like an odd number, and then you have to get a middle. So you have like an odd number. And you can get a middle, or you can just keep going, right? And you can get a different middle, or you can just keep going. Is that what this is? One, 5. Why? Yeah. Why? Why? Aha. Okay, yes. 200, 300, 400, 500, 600, 700. Okay. No, that doesn't work. Okay, yes, okay. So as long as you don't map to the same sum. 60. And that's n squared. Okay, cool. Alright, solution has been broken. That's a shame. Like you want to get a bunch of middles. Like you want to get a bunch of potential middles. Where you can just keep on dragging them over. You can keep on dragging them over for a cost of 1. And that's your opt. Or you can get a new middle for a cost of opt plus 1. Yeah. Okay, sure. Alright, I understand my own code now. So now let's write the smart part. Okay, so we need alternating prefix sums, which is really cool. That's really cool. That's really cool, man. That's really cool. So So we need this prefix sum, then this prefix sum. So we need like, Turs solved this in 30 minutes, by the way. If you ever wondered the difference between Turs and me, crazy stuff, man, crazy stuff. This round got me to 2,500. Yes. Okay. All right. There's a chance we don't finish this tonight, but I will hope for the best. I'll hope for the best. Hope for the best, right? That's all we can do. Hope for the best. So we need a lift function. And what it's going to do is do the alternating sums, right? So what we need is this. So if you exist in this plane, if you exist on this interval, then to lift you, you need this alternating sum. So this minus this plus this minus this minus you. This minus this plus this. So if you're at odd distance, we negate you. We do the freaking alternating sum. Germany, nice. What? I don't know time zones that well. Is it? It's starting to be morning for a lot of people, right? At this point, it's 9:30 p.m. for me. Okay, I don't want to start coding this. I don't want to start coding this, man. I just don't. Oh boy. Well, once I start coding this, I can't stop. I'm not gonna be able to stop. If we go to 11, I'm just gonna cut it short. We'll see. I think I'm gonna stop the coder after this week. I'm kind of getting tired of it. Oh, 3 in the morning. Nice. That's not ideal, I guess. Although a couple of months or a month or so ago, my sleep was a lot worse, so I can't really be the one to judge. What are we doing? So we need the alternating sum. Okay, so V out PS. Okay, A V out B N. For Li 0 is N. F is equal to 1 if I mod 2, F is equal to negative F. R plus equals AI times F. PS dot push. PS is equal to BL. Okay, so we need to create this lift function. Using T is equal to array L3. T x is equal to ps targ minus ps a2 if targ mod 2 is equal to 1, x equals negative x. Ah, god damn it! No, stop. Okay, don't look at that. That's it's impossible to avoid spoilers for rounds. It just is. God. Okay, I didn't see anything, but that could have been bad. So if targ minus a2 mod 2 is equal to 1, r dot f equals negative r dot f, r dot s equals negative r dot s. R dot f plus equals x. Okay. PL lift TA. Why? I didn't. Okay. PL lift TA. So PLR is A0, A1. LX is PS targ minus PS A2. If targ mod 2 is 1, x is negative x. Yeah. If targ minus A2, so that's the index, mod 2 is 1. If we have an odd number of things, negate, add x, return. Now, shoot, wait. No, okay, we're allowed to, yes, we can insert you back. Yeah, that's okay. Okay. Okay, so PL lift TA LO target. Now, A0 is equal to R dot F, A1 is equal to R dot S. No, we didn't even need to. A0, A1 is equal to negative A1. Okay, so how does this work? I still have to freaking look this up. Okay. We don't have C++ 20. Okay. So auto scomp. Shoot. Problem is this is going to invalidate our ordering, right? Let me do this, right? Okay. Stop it. So we can sort you like this. So this is stupid, but return lift a and minus 1. Okay. Can we like... Yeah, I need you to be a function. Comp. Set t decal type comp. Okay. So dec s dq. Okay, so if a0 mod 2 is 1, a0 mod 2 is 0, a dot insert you're gonna frickin' thank you. I is 1, I is less than n, I plus plus. Okay, so oh no, we need to, yeah, we need to do backwards stuff. So we'll search LX. No, we don't need to. We need to put this in a function. Yes, we should, because we're gonna use it twice. T-targ is equal to xxi. Auto it is equal to s dot lower bound targ. It is not equal to s dot end. If r0 is less than or equal to x, and x is less than or equal to r1, return 1. Okay, yeah. Okay, so if AI mod 2 is equal to 0 and search DQ0, AI over 2 I DQ0. DQ.push s.insert AI over 2, AI over 2, I. S. If search AI over 2, I DQ2, DQ So if search AI over 2, I DQ2, then insert it into DQ1. AI mod 2 is 0, and search AI over 2, I dq 0. So insert AI over 2, AI over 2, I. So right, so we have u push dq1 dq.size okay, else for I 0 is dq.size I plus plus trim dqi. So else so we can extend opt. So we could do middle for opt minus 1, or we could extend opt. Or we could do middle for opt minus 2, right? No, I did not used to train this way, nor do I recommend it. I just feel like doing it right now. Like I'm able to do it. I have the time. I want to put in the time. Like I really want to. So I am, but I did not do this before reaching red. No, and I probably would not recommend it. I mean, if this is nothing more than a frivolous hobby to you or something like that, it's not worth putting this amount of time in, like objectively. Like do other things with your life, you know. But I've decided I'm taking this very seriously, so I'm going to make LGM happen as fast as possible. That's the intent. Plus K, and streaming it is just a way to hold myself accountable. That's the idea with it. Okay, so here are our cases, right? PL is less than or equal to PR. So we push U to T plus 1. So anything in opt goes into opt plus 1. Anything in middle, if we have a middle, it'll stay. So here we don't care about this case, right? If dq.size is 1, yeah, no, okay. For I 0, I is less than Ti plus plus. K 0, K is less than T, K plus plus. ss equal to ns, s dot insert. So you're 1 ai minus 1 I dq dot push back s. Okay, now we know that we don't have you, so there's that case. Or we could continue, and then if search and then push dq1 t 1 ai minus 1 I. If search ai mod 2 is equal to 0 and search ai over 2 I dq1 t is greater than 1, and search ai over 2 I dq1 push dq0 this. Push dq1. Okay, so void push ss tt bool isect tatb a0 is max a0 b0 a1 is min a1 b1 return a0. Now we're gonna assume you're lifted. Okay, so while 1 auto it is equal to s dot lower bound t, if it is not equal to tr is equal to star it. If isect r is lift r, if isect tr break s dot erase r
T is unite tr. tr star t, okay. S dot insert t. Wow. S dot size. tr. If if TL G is equal to L, break. S dot erase R. If G0 is less than or equal to G1, S dot insert G, break. Okay, same thing here. Okay. What are the odds that this works on the first try? 0, right? Like literally 0. Yeah. Okay, so oh, that's why. Yeah. So PRDQ. Why are you 2? What? Yeah. 330. Three three zero 150, right? So we have 330. K is 1. Trim is not working. Why? -3, -3, 0. G2 is equal to I. Left TI is -3, -3, 0. R, L, I. What? What is I? R, L, I, T. T is 150. What? Trim. Ah. DQT. That's why you don't reuse variables, man. Okay. So while DQ dot size greater than 0 and DQ 0 dot size equal to 0 plus K DQ dot pop front. Cool. Okay. Wait, now you're mega wrong. Shoot. Okay, so 1, 2, 3, 3. All right, let's just try. You should be 2. No, you should be 3, sorry. Yes. K is 4. Q is 1, 2, 0. Okay, so lift is wrong, right? Swap A0 and 1. There we go. Nice. Okay. Yeah, okay. So K is 3, right? So 180. So we have 180, right? How are you already 3? Wait, no, wait, what? So K is 1, K is 2. If AI mod 2 is 0, and search AI, okay, so we need to fix you. PLXR. What the hell's PL? You don't get there. PR targ S. Targ is 111, S is 180. I is 1, right? Yes. So lift U. So you're going to be lifted to N minus 1, which means you're going to become -7 to 1 to 0. Which means you're going to become 1, -7, 0. Okay. Sure. I'll put that in the if condition. Okay. Cool. We pass the sample now. Nice. Okay. PRNA. Damn. Okay. Cool. Nice. 4, 4, 1, 1. Yes. Okay. So 1, 3. Do you work? Make it as small as possible, right? Yeah. So 4, 4, 2. Okay. So cool. Let's just read the code. PS is VLN. F is -F. PR PS. PS is 402. Yes. You're negated. So DQ. Okay. Dec S DQ. S dot insert A0/2, A0/2, 0. 1 is 0 minus 1, 0. Yeah. Plus plus k, ss is in s. So if ai mod 2 is 0 and search ai over 2, I dq 0, ss is in s. dq.size is greater than or equal to 3 and search ai over 2, I dq 2, because we're pushing to front. Yeah, put you there. Else plus plus k. ai mod 2 is 0. Push dq 0, yeah. Well, dq.size is greater than 2, dq.pop back. Oh, we might actually care about. Does it actually matter? No, it's not the issue. It is an issue though, so that is worth doing. For auto SDQ, for auto TS, yeah, that's all printing. Okay. G's gsect. If you're safe, fine. Otherwise, erase it. If you're still a valid interval, then insert you and then break. Do the same here. While 1 on IT is s dot lower bound t, if IT is s dot end break, tr is star IT, r is lift ri. If isect, s dot array star IT, yeah. Okay. Sure. Okay, so what's going on? Okay, we have so much trash here. Where is RLIT? What's the issue, actually? So we have 221, 221. K should not be 2 here, right? So K should be 1. Okay, organization, please. I is 1. So K should be 1. I is 2. K should be 2. Oh. We don't need to... Oh. Okay. We don't actually need to do that at all. I see. Okay, back to stress. Damn. Ans is 2, Jur is 3. It's a pretty small case, too. It's the power of stress. Makes life so much easier. If you don't stress test, by the way, I absolutely recommend it. It's just like it's a lifesaver, dude. Like honestly, it's genuinely a lifesaver. Like it actually, I would have suffered so much during these streams if not for that. Okay, so. So DQ is 550190, true. Then K is 2. We're going to have 5, 5, right? If idiot. Okay, yes. Cool. 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 Alright. Alright, let's do it. GG's. I didn't print the answer. Whatever. Wrong answer on test 1. Work. He's still gonna TLE. The constant, yeah, the constant factor is okay. Actually, yeah, I can see that. All right, fine. We're gonna have to make this a lot faster, huh? Let's see how slow you are. Don't save. Stop it. Wait, what? Okay. Let's try the counter case. A0 is equal to 555. A1 is equal to A I is equal to AI minus 1 plus R. Cool. Cool. Do we have something that makes it n squared, or is the constant just that bad? Is the constant just that bad? What? How? Okay, that's n squared. Why are you n squared? How are you? That's worse than n squared. Okay, let's get rid of push. Deck can handle it, right? Okay, the issue isn't push. Well, actually, obviously. Let's go to trim. Oh my god. Oh, you idiot. Okay. Okay. You gotta be more careful with that, man. You gotta be more careful with that. Holy Christ. Okay. What a what a dumbass. God damn. Okay. Sure. You might still TLE. That's so dumb though. That's actually so dumb. Ugh, fine. Okay, this is actually a constant issue, right? I didn't solve it yet, don't worry. Let's try this. Let's try a bunch of small things, right? No, it's not the issue. Are you the issue? You could actually be the issue. What? What do you mean? What do you mean runtime error? What do you mean runtime error? What do you mean? Oh. Okay, sure. I didn't solve it yet, don't worry. Don't worry. You're fine. Okay, so it's the big case, that's the problem. Right. But it's constant factor. We can make you all int. And you'd overflow, but where? Actually, no, we cannot make you all ints. Because the alternating sum will die. Can we use pragmas? Probably not, right? Let's... It's probably not faster. It's faster. That's faster. Holy crap. Why is that so much faster? Nice. Pragmas. Very nice. Okay, that was 32. Damn. So F was harder, even though E had fewer solves because Codeforces logic. Actually, did E have fewer solves? There might have been some solves down here. There's one solve from that guy. But other than that, 1, 2, 3, 4, 5, 6, 7. 7 solves versus 2, 3, 4, 5, 6, 7, 8, 9, 10 versus 9 solves. And yet
E is lower rated. That makes sense. That makes so much sense. Okay, well, we've solved all the problems from this div 1, which is a cool feat to have, I guess. Nice. Good screenshot. Good screenshot. Okay, well, I don't have much more to say. We're finished for now. You can say no now. I got the problem. Yeah, so that's cool. There are some old div ones for which that property is also true, but the older it gets, the easier it gets. These are like 32, 33, so that's not bad. Okay. Same plan tomorrow. Next week I'm gonna do something other than ActCoder. But other than that, same plan. There might be a team who would want to train alongside me for ICPC, which I might do. So there might be a day where I just like do an ICPC contest instead. But stream will continue tomorrow. If you have questions, join the Discord. I don't think, do people do that? I don't know, but I don't think that many people do that, but whatever. Yeah. Okay. Cool. See ya.